Hello everyone, my name is Clarence Gibson-Lee and this is my CSC211 honors project for spring 2026 under the supervision of Dr. Azar. And my project is called Nutrient Tracker and it focuses on accessible health, nutrition, and daily wellness tracking. Many nutrition apps focus mostly on calories, protein, carbs, and fat. The problem is that the users often do not see enough information about important micronutrients like magnesium, iron, and vitamin B12. My solution is a C++ and Qt desktop app that helps users enter foods they eat and receive a full nutritional breakdown. The app calculates both macronutrients and micronutrients. What it does, there's I can type food like 2 eggs, 1 cup of rice. The program identifies the food, checks the database, calculate nutrients, and give a daily summary. I chose this solution because I wanted users to better understand their nutrition, not just their calories. This app gives more control and deeper health information. The algorithm. First, the app loads the database. Then it takes user input, parses the food, matches it with the database, converts units to grams, get nutrients, scale the values, and add everything into daily totals. The project uses a 3-layer design: UI, logic, and data. The UI is built with Qt, the logic handles parsing and calculations, and the data layer uses SQLite with USDA nutrition data. I built the project as a C++ desktop application using Qt. SQLite stores the nutrition data, and the app is organized into folders so each part has a clear job. Here, I show where classes are implemented. For example, Database Manager handles the database, Meal Analyzer handles the nutrient process, and Main Window, Main Page, and Welcome Page handle the interface. This slide shows inheritance. Some classes inherit from Qt classes, and I also added a custom parent class called Core Component. Input Parser, Food Matcher, and Unit Converter inherit from it. This slide shows real exception handling. Unit Converter throws an exception if the food quantity is invalid, and Meal Analyzer catches it so the app does not crash. One challenge for me was setting up Qt Creator and Simic correctly. Another was working with the large USDA database. I also had to handle user input carefully, including empty input and unmatched foods. When the app opens, the user sees a welcome page with the project topic, my name, the professor's name, and the semester. After clicking start, the user enters the main dashboard. The dashboard shows calories remaining, macro progress bar, a food input section, a recent food list, a daily log, and a full nutrient breakdown. The user can type food such as 2 eggs, 1 cup rice, and banana. Let's try it. The user can preview nutrients. The user will know the amount of nutrients they're gonna get. Let's try it. The app asks the user if this is what they mean. In my case, I will say yes. Now, if the user scroll all the way down, the user will see the amount of calories they will get, the amount of protein, the amount of carbohydrate, the amount of fat, the amount of sugar, etc. Now that the user sees the amount they will get, they may add this food in their daily log now, and then they will be able to see their calories intake. And as we just saw below, let's add the food. Let's click yes. As you can see, we have the amount of calories left for the day, the amount of protein intake, the carbs, and the fat. But how does this work? The app reads that input, separates each food item, checks the quantity and unit, and searches for matching foods in the database. If the food is found, the program calculates calories, protein, carbs, fat, fiber, vitamins, and minerals. If the food is not found, the app displays a warning or suggestion. Let's try it. As you can see, the app displays a message stating we can provide information about this food. For the backend, the app uses a SQLite database with nutrition data from USDA Food Data Central. The code is modular. The models folder stores the data structure. The data folder handles the data pass in USDA importer. The core folder handles the main nutrition logic, and the UI folder handles the Qt interface. This makes the app easier to understand and easier to improve later. I created a custom parent class called core component. This parent class has a virtual function called component name. Then class like input parser, unit converter, and food matcher inherit from core component. This is inheritance because these child classes are using a common parent class instead of being completely separate. In this example, the public component part shows that this class inherits from our component. Here I'm showing exception handling using throw, try, and catch. And unit converted at CPP, the program checks if the food quantity is less than or equal to 0. If the quantity is invalid, it throws an exception using invalid argument. And meal analyzer at CPP, the conversion is placed inside a try block. If unit converters throws an exception, catch block catches it. Instead of crashing, the app adds a warning message and skips that invalid food item. And this is my algorithm flowchart. The app starts by showing the welcome page. When the start button is clicked, the main dashboard opens and the program checks if the SQLite food database is available. If the database is missing, the app tries to copy the bundle database file into the app data folder. After the database is ready, the user can type food input such as 2 eggs, 1 cup of rice, banana, and the program checks if the input is empty, asks the user to confirm it, then parses the food name, quantity, and unit. The app also searches the database for each food, and it also converts the quantity into grams, get the nutrient values, scale the nutrient, and calculates the final total. This UML diagram shows the structure of my nutrient tracker app. The app is divided into 3 different sections: the user interface, the call logic, and the model data structures. Some classes inherit from Qt classes, such as main window inherit from Q main window, welcome page, main page, color ring, about page inherit from Q widget. I also add my own custom parent class called core component. The class input parser, food matcher, unit converter inherit from this parent class core component. The middle part shows the core logic of the app. Meal analyzer connect the main logic together. It uses input parser, food matcher, unit converter. It uses input parser to read the food text, food matcher to find foods in the database, unit converter to convert units into grams, nutrient engine to calculate nutrient totals. At the bottom part shows the database and model side. Database manager handles the SQLite database, and USDA importer imports USDA nutrition data. The model structures like parsed food item, food record, nutrient value, analyze food item, analyze result, store the information that moves through the program. In the future, I would like to add user account, save meal history, barcode scanning, mobile support, and CUNY wellness resources. Overall, Nutrient Tracker helps users understand their daily nutrition in a simple and accessible way. Thank you.